Hi, I'm Lara from Geoscience Australia, and today we're in the foyer of the building looking at some instrumentation that we use to measure earthquakes. So, what is an earthquake? Well, an earthquake really is just the shaking of the earth, and the ones that the scientists at Geoscience Australia are interested in looking at are caused by the movement of tectonic plates. The instrument we're going to look at is this one here. So this is called a seismograph, and it's recording movements of the earth that are detected by a sensor that's down underneath the ground. So the seismometer is an instrument about the size of a soccer ball. It is the sensor that's touching the rock way down there under the ground. So when it's touching the rock, it means it can feel vibrations as they travel through the earth, and it can detect even the tiniest of vibrations, and then it sends a signal to the seismograph up here on the surface. So the seismograph is turned on all the time, and as you can see, there's a long arm at the top with a pen at the end. So arm with a pen, and then a drum underneath has a piece of paper on it, and that drum is very slowly turning. So for most of the time there are no vibrations, and so there's just a straight line. But when an earthquake is detected, the pen will move back and forth and give us a nice distinct scribble. So this drum takes 1 hour to do a full rotation, and over the course of 24 hours the whole piece of paper fills up, and then we change the paper. We regularly detect earthquakes in Canberra that have happened in other parts of the world. So let me show you a couple of seismograms. This is the first one. So this is from an earthquake that happened in Christchurch in New Zealand back in 2011. So it's a magnitude 6.3. As you can see, it's a nice clear signal. In Christchurch, the earthquake hit just below the city. Many buildings fell over. Some people lost their lives. So it was a disaster for New Zealand. Here in Canberra, we've got a clear signal, but nobody would have felt it with their feet, even though we're 3,000 kilometres away. This is the other one I wanted to show you. This was the Japanese earthquake from 2011. It was a magnitude 9. And as you can see, it really is a very big signal. It was a very big earthquake. In fact, it was the 4th largest earthquake ever recorded. And these are two that you might study at school. So those recordings were done on paper. You can imagine that Geoscience Australia scientists don't travel out to the 60 seismometers in their network around the country every day to change the paper. In fact, those seismometers are set up in little huts with their own communications equipment so that they can send their signal directly up into the internet and back down into the computers of our scientists here. So we have an earthquake alert centre in the building, and there is a scientist, a seismologist working there 24 hours a day, 7 days a week. Maybe you'd like to do an experiment on earthquakes at home. Do you have one of these? Or perhaps a tablet? The thing that's in here that can detect whether your phone is upright, sideways, upside down is something called an accelerometer, and it's the same technology that's in seismometers. There are plenty of free apps out there to do earthquake detection using that accelerometer. So if you download one of those, you can do experiments where you put your phone on the bookshelf, on the floor next to you, stand further away or stand closer, and see what sort of differences you can detect.